Hi everyone, I hope you're all doing fine. In a special way, I'll take this opportunity to thank Mr. Junju Isaac of Boston High School in Entebbe for liking, subscribing, and tuning in always to follow my channel. Thank you so much, Mr. Isaac, and your students. I am very happy that you like my work and you always follow what I do. I'll dedicate this lesson to you, and in today's lesson, we are going to continue looking at integrational products of sines and cosines, but of a special type. Let's see what type it is. Well, this is simple to integrate, but the sensitivity lies on which power is odd. Okay, if m is odd, if m is odd, okay, then n minus 1 will be even. Okay, so what does it mean? It means that the sine of m minus 1, okay, of x can be expressed in terms of cosine of x. So what will be the method? The method is simple, okay? You let t equals to cosine of x, okay? Yeah, so how do we express sine m minus 1 in terms of cosine x? It is simple. Remember, we talked about it, okay? Sine squared x is equal to 1 minus cos squared x. This relation will work for all even powers, okay? So it is really very simple, and this is the method. Now, what if, okay? What if n is odd? Then n minus 1 will be even, okay? And the cosine this time, not sine, and the cosine of something has to be done before, okay? And the cosine of n minus 1 of x can be expressed in terms of sine x by cos squared x, the same thing as 1 minus sine squared x. That's the Pythagorean identity, okay, which we get from opposite squared plus adjacent squared is equal to hypotenuse. Okay, it can also be written as sine squared plus cos squared is equal to 1 for whatever angle you're feeding. So it is an identity. So here we make the substitution. T equals to sine x, and then in the process of changing the variables, okay, the cosine will cancel out. Let's see, without looking at an example, it becomes hard for a student to understand, but this is really so easy. Let's look at an example and see what we can do here. So this example, they want us to find the integral of sine cubed x cos of x by dx. Now, here, both powers are odd powers, but you discover that it is easy to express sine cubed of x in terms of cosine by this what we do. Okay, in the solution, we know that sine cubed x is the same thing as sine squared x times sine of x. Okay, so this sine squared x can go to cosine by the Pythagorean identity. So this 1 minus cos squared x, then times sine x. So if we feed this in the equation here, okay, let me feed in. If I integrated the sine cubed x, okay, then cosine of x by dx, the same thing as integrating 1 minus sine squared x, okay, no, it's 1 minus cos squared x, and we change it. So same thing as integrating 1 minus cos squared x, then times the sine x, and then times the cosine of x by dx. Okay, so here, if I let t equals to cosine of x, this will help me cancel out this sign, okay, if I make this substitution. That's why we are saying that if you are given a product of trig function with the powers, then what you do, look for the one that is carrying the odd power, okay? And that's the one that you can easily change in terms of the other. So the one with the even power or the other power, you substitute, you call t that substitution, and then it will be easier for you to integrate. So the other task we have is to change dx so that it's defined in terms of the t. Now, if you differentiate here with respect to x, you're going to get dt by dx is equal to negative sine of x. So that dx, okay, is the same thing as dt over negative sine of x. So what does it mean? The integral of sine cubed x times cos of x by dx will again change to, okay, integral of 1 minus t squared, then times sine of x multiplied by t, then the t over negative sine of x. Okay, so this cancels out, but don't forget about that negative. It is gonna factorize. Okay, so life is now getting simple. Okay, so the integral changes to the negative integral of 1 minus t squared into t. You multiply through by t before integrating. But if I multiply through by t and integrate, then I'll get a negative t squared over 2, okay, minus a t to power 4 over 4, then plus a constant of integration, okay? And this will be a plus if you open brackets. So that's what we get, but we have to substitute in terms of t. What was t? T was cosine. So this is cos power 4 of x over 4 minus cos squared x out of 2, then plus the constant of integration, that's the integral. Example 2, they want us to integrate sine squared x sine 2x by dx. So this is a simple question that can be done in two ways. One of the ways is to use what we have just discussed, and if you are to use powers, products of powers of sines and cosines, then in the solution, you need to write sine 2x as 2 sine x cos of x. So if you have sine squared x multiplying by sine 2x, then this is as good as writing 2 sine cubed x, then cos of x. And then we go ahead and integrate this. So integral of sine squared x sine 2x by dx now becomes twice the integral of sine cubed x, then cos of x by dx. This is 0 to pi over 4. 0 to pi over 4. But you know, this is like the first example, so we shall not bother ourselves going through the same process. Okay, this is cos power 4 x over 4 minus cos squared x over 2 plus c from 0 to pi over 4. Okay, so the task you have is to substitute in and get the answer. C will cancel out in the process of subtracting the lower limit from the upper limit, so don't worry about that. Substituting in the limits, we're gonna get 2 into this is equals pi over 4. This is to power 4 over 4 minus cos pi over 4. This is squared over 2. Then minus the lower limit. The cos of 0 is 1, so this 1 over 4 minus 1 over 2. Okay, but you know the cos of pi over 4 is 1 over root of 2. Okay, if you want, you can write root out of 2. But you know, if we rationalize, or if we leave it in as 1 over root of 2, squaring 1 over root 2, you get a half, and then squaring it again, you'll get a quarter. So this is 2 into 1 over 16 minus 1 over 4. Okay, so then minus the lower limit, which is thrice into, okay, that is a minus 1 out of 4. So you go ahead and simplify this, see what you get, and that will be the answer. Look at example 3. They want us to integrate sine cubed x cos cubed x by dx. So still here there are 2 ways of going about it, but let me use odd powers. Okay, and product of odd powers. Here let me change cosine in terms of sines. So I write this as the integral 0 to pi over 2 sine cubed x. Then cosine I write as 1 minus sine squared x, then cosine of x by dx. You know, cos cubed is cos squared times cos, but cos squared is 1 minus sine squared, so this is standing for cos squared. Now, what do we do? Okay, so what we do is just simple. Let u equals to sine of x, because when you differentiate sine, it will give us a cosine, and this part will go. Okay, so what do we mean? Du by dx is the cosine of x, and if we want, we can guess that du is equal to cos of x by dx. So it means that the whole of this part is du. Okay, so we do then. Okay, so we can also change limits, so we don't bother making a back substitution. Here we have u, x and u limits. U, remember, is equal to sine of x. So if I change the limits, I will have x limits. They are from 0 to pi over 2, or the same as 90. The sine of 0 is 0, and the sine of pi over 2 is 1. Okay, so it means that our integral, the integral from 0 to pi over 2 of sine cubed x, then equals cubed x by dx. We're now changing from 0 to 1. Okay, remember now u is sine x, so this is u cubed, okay, minus u to power 5. That's multiplying the sines. Okay, then by du. Why? The cos of x dx is du. So what do we get? Let's go ahead and integrate this. This is u to power 4 over 4 minus u to power 6 over 6 from 0 to 1. Substituting the upper limit, we get 1 over 4 minus 1 over 6, then minus 0. Okay, so that's enough to somebody just get your pocket calculator, compute this, and you have the answer right away. 1 over 4 minus 1 over 6. The LCM is 12. 12 divided by 4 is a 3 minus 2 out of 12, which is 1 over 12. That's what I'm getting. So that's the integral of sine cubed cos cubed by dx. But I also give you a hint about this. You can also look at sine cubed x cos cubed x as a sine x cos x then cubed. But sine x cos x is a half of sine 2x then cubed. And this is going to be 1 over 8 over sine cubed of 2x by dx. You separate sine cubed in terms of sine squared and sine. Then you can still use this method. It is one of the ways of solving the problem. But I find, the method I've used, I find it very simple to me. Maybe it is also simple to you. Try it out and see. All right, ladies and gentlemen, this is a short lesson I've done for you. You can try to get your understanding with these two questions and see how far you have mastered the content. Okay, I remind you, don't forget to subscribe and to click the notification bell. That way, if I upload a new video, you're going to be notified instantly. And also don't forget to share this link with your friends who are in. Don't be mean. You know, this knowledge, I've done it for you. It is free. You just need to get your mobile data or Wi-Fi, go to YouTube. Okay, I've done a couple of lessons before. You can go to actually YouTube, you can search for Erisa Wante, then so many lessons will pop up and to be self-service. But don't forget to share with your friends. Okay, so many people in need. This is a hard time. Let's be with each other. Let's stand with each other in all aspects of life. But my aspect, I'm handling the education part of it. So ladies and gentlemen, I wish you the best of this and the best of luck. Have a nice day.